Okay, this video is going to be all about slope fields. We've got one learning target to focus on, and that is how to use slope fields to approximate solutions of differential equations. So we've got the definition of a slope field and some examples to look at. Definition of a slope field. So solving a differential equation analytically can be difficult or even impossible. However, there is a graphical approach you can use to learn a lot about the solution of a differential equation. Consider a differential equation of the form y prime equals big F of x comma y. That's a differential equation, and remember, all that a differential equation is an equation that represents the derivative. So at each point x, y in the xy plane where big F is defined, the differential equation determines the slope y prime of the solution at that point. So if you draw a short line segment with slope at selected points in the domain of big F, then these line segments form what we call a slope field, or sometimes also known as a direction field for the differential equation y prime. Each line segment has the same slope as the solution curve through that point. A slope field shows the general shape of all solutions. They're really quite simple to make, and they give us some very valuable information, but the big idea comes right from the name. It is a field of slope. So if we go to the Unit 7 curriculum map, in the Chapter 6 review portion, it tells us the only significant note for slope fields is that dy dx is the same thing as y prime, and both of those things represent slope. So if you're given a differential equation, then any values you get out of that equation represent slopes for that differential equation. So it is, like I said, a very simple concept, and let's take a look at some examples of how to put this idea to use. So our first example says sketch a slope field for the differential equation y prime equals x minus y for the points negative 1, 1, 0, 1, and 1, 1. So as I take a look here, the first thing I want to make a note of is that y prime is the same thing as dy dx. dy dx, y prime, these all represent slope. So if I want to know what the slope is at any given point, and I have the differential equation that represents slopes, then I can simply plug in the corresponding x and y values. There's an easy way to do this. One of the ways is to make yourself a little chart. So what you can do is make a chart. It's kind of like a T-chart, but it's a little bit bigger because we're going to have an x value, we're going to have a y value, and then we're going to have our slope value. So in this case, y prime is simply going to be x minus y. So for the point negative 1, 1, I put in a negative 1 for x, I put in a 1 for y, so negative 1 minus 1 is negative 2, and that represents my slope at that point. For the point 0, 1, I put a 0 in for x, a 1 in for y, and then I take 0 minus 1, which gives me a negative 1, and that represents the slope at that point. And then for the point 1, 1, I put a 1 in for x, a 1 in for y, and 1 minus 1 is 0, which represents the slope at that point. So if I want to sketch a slope field for these points, all I need to do is take a graph, and then at those points I will draw a little line segment that represents the slopes. So I'm going to scroll down here, and here is the graph. So at the point negative 1, 1, if I go back up to my table here, I need a slope of negative 2. So I draw a little line segment that has an approximate slope of negative 2. Now how would I get that slope? I would use a straight edge, and I would use rise over run. So from this point I would go approximately down 2, right 1, and then I would draw that little line segment. But I only make my line segment at the point. At the point 0, 1, I have a slope of negative 1. So I go to the point 0, 1, and to get this slope here of negative 1, I simply would have gone from this point and went down 1, right one and use the straight edge. But I wouldn't draw one big line here. I would just draw a little line segment at that point. And then at the point 1, 1, we have a nice slope of 0. So that's about as easy as it gets. A slope of 0 is represented by a horizontal line. The other slopes that are easy is when we have a slope that's undefined, we would make ourselves a vertical line instead of a horizontal line. So that's one example of how a slope field question might look. Another example would be, given these slope fields, match each slope field with its differential equation. So you're given 1, 2, 3 slope fields, A, B, and C. And if I scroll down here, it gives 3 differential equations. So how are you going to decide which differential equation goes with each slope field? And the answer is, we just pick some points. So when I look at my A graph here, I see that I have slopes of 0 anywhere that x is 0. So this is a point 0, 0. This is a point 0, 1, 0, 2, 0, 3. So if I look at my options here for my differential equations, you can see that my first one, x plus y, won't work. Because if I plug in the point 0, 0, well, that's fine because I would get a slope of 0. But what about the point 0, 1? 0 plus 1 is 1, wouldn't give me a slope of 0. So A cannot be I. What about II, or I guess 2? Can 2 match with A? Well, yeah, because anywhere that x is 0, my slope is 0. In fact, anywhere my x is 1, my slopes are 1. Anywhere my x is 2, my slopes are 2. So the correct answer for A is that it matches with the second differential equation. So for B and C, they're either going to match with 1 or 3. So when I look at them, I would plug in some points and go from there. If I did that, I would find out that B matches with 1. So I could plug in some points to determine that. And then C matches with 3. The other type of slope field equation that we oftentimes see is one where you're just asked to sketch it. And then use your slope field to sketch a solution that passes through the point. So if I was given a differential equation, I could make a big table like this and find a whole bunch of slope values. And then I could draw a whole bunch of, slopes at various points. And then the next part to it would say, okay, now draw the solution through a given point. So in this example, if I go back up to the top, it said, let's draw the solution that passes through the point 1, 1. So once I had my slope field, I would then go to the point 1, 1. I would make a point, and then I would follow the slopes to the best of my ability. And you can see I'm not doing a very good job of that, but it would be represented by that sketch. Over here, I'm going to just pick a different starting point. Let's say instead I started at the point 0, negative 1. If this was my starting point, then my sketch would look something more like this. Okay, so that is the idea of slope fields. Like I said, a very simple idea, and there were some examples there, and hopefully at this point you would now be able to go back to the bell work question and determine that the slope field that matches with the differential equation given is E. And again, the way you would do that is plug in some values, find a point, and just test which one works. The answer ends up being E.